Aerial skiing, skiers ski down a hill of snow, then up a ramp and into the air where they do various tricks and then land in the snow below. Friction. Skiers put wax on the bottom of their skis to reduce the friction between their skis and the snow. With less energy escaping in the form of friction, more of this energy is kinetic, which means that the velocity of the skier is greater. Velocity. With less friction, the skier will have a greater velocity. With a greater velocity, the skier will go higher in the air after leaving the ramp. Therefore, the skiers wax their skis so that they have more time in the air to perform their tricks. Air resistance. Also to increase their air time, skiers crouch and wear skin-tight suits and helmets so that they move faster through the air. Both the wax skis and the skier's clothing combined with the crouching ensures that the velocity is as large as possible, so the skiers have the most time in the air to perform their tricks. Surface area. It may seem obvious, but wearing skis helps skiers glide over the snow. The added surface area of the ski, as opposed to just the bottom of a shoe, distributes the same weight over a larger surface, helping the skier to stay on the surface of the snow as opposed to sinking in. Takeoff. After the skier leaves the ramp, she is in free fall because the only force acting on her is gravity. As we studied earlier in the year, the skier will move in the shape of a parabola because her horizontal motion remains constant, while her vertical motion changes because of the acceleration of gravity. Tricks. Skiers often perform tricks while spinning in the air, so to manipulate their motion, they use their limbs to adjust the rate at which they spin. Inertia. Inertia is defined as a resistance of a linear force. Moment of inertia refers to a similar situation, but instead of straightforward linear motion, which is regular inertia, moment of inertia refers to rotational motion. Equation for moment of inertia. The letter I represents moment of inertia. I is equal to the sum of the mass and the radius squared of the spinning object. Angular momentum. Angular momentum also concerns rotational motion. Just like regular momentum, angular momentum is conserved. The letter L represents angular momentum. L is equal to the mass times the velocity times the radius of the spinning object. If angular momentum is conserved, and the mass of the skier does not change while they are spinning, if the radius of the skier is increased, the velocity will decrease. If the radius is decreased, the velocity will increase. This is the reason why when figure skaters pull their arms closer to their bodies, they spin faster, and when they stick them out, they spin slower. Aerial skiers do similar things with their bodies to manipulate the way they move through the air to perform tricks. Landing. When skiers land, they bend their knees to reduce the impact on their bones. Because the force times time equals the mass multiplied by the change in velocity, the greater the time, the less the force. By bending their knees, skiers reduce the time it takes for them to land, therefore decreasing the force on their bones.